Welcome back to Algebra with Mr. Farina. Today we talk about function notation. The second semester so far we've talked a lot about this function idea, and most of the equations we have dealt with in function, or equations of functions we've dealt with, have been in the form y equals like 3x minus 5. But what happens if we have a graph or a bunch of different functions that we are given? If we name them all y equals, how do we tell which one to use? Well, what mathematicians came up with is what we call function notation. Instead of using y equals, what we do is we replace y with a function such as f, and we put in parentheses the input value of that function. So when you see this concept, or this equation, f of x equals 3x minus 5, we read this as the name, which is function f, alright, that is the name, this x is the input value, and we read it f of x, meaning the name with respect to the input value x. And again, the reason we do this is, in life, we assign people a name to tell the difference between who is one person versus another person. Same thing with a function. We may have graphs in the future with 2 or 3 functions graphed on it. How do we tell which one is which graph? Alright? And we name them. So we might name one function f of x equals 3x minus 5. Then we might have another function, such as g of x equals, x squared minus 6. And then we might have h of x equals 5x. So that when we graph these functions, right, then we can basically label that graph with the name of that function. So how do we evaluate these functions? Well, if we look at example 1, we're given f of x equals 3x minus 5. They want us to evaluate f of negative 4. Remember, f of x is just another way of writing y. Okay? So this is just like y equals 3x minus 5. Right? But what we're given here is evaluate function f using the input. This here is the input value. So we say f of negative 4, that's my input value, is equal to, now everywhere in this function I see an x, I'm going to replace it with negative 4. So 3 times negative 4 minus 5. Now I can go ahead and evaluate that. F of negative 4 equals negative 12 minus 5. So f of x equals negative 17. F of negative 4 is equal to negative 17. So now when I evaluate f of 0, alright, now instead of replacing every value with negative 4, now it's telling me to input 0 in the place of x. So in this case, we would do 3 times 0 minus 5. What's 3 times 0? 0. 0 minus 5 gives you negative 5. So f of 0 is equal to negative 5. Okay, next one. Evaluate f of 6. Well, now wherever I see an x, I'm going to input 6. So 3 times 6 minus 5 gives us f of 6 equals 18 minus 5. So f of 6 is equal to 13. Now the nice part about function notation is it gives us an easy way to write our ordered pairs also. Because remember, if we input a value, we get an output value, and we write our ordered pairs as input, comma, output. Meaning you input x, you get your output y. So when we look at our ordered pairs here, our input value is negative 4. What was our output value? Negative 17. If we input 0, we get an output of negative 5. And if we input 6, we get an output of 13. So this allowed us to, pretty much write our ordered pairs fairly easy without having to use a table of values. So example 2, if you notice, we are given 3 functions. We're given f of x, we are given g of x, and we are given h of x. Now, we're asked to evaluate several different functions with different inputs. So, looking at letter A here, when I go to evaluate letter A, it says evaluate g of 3. Well, which function has the name g? Well, the function g tells me I have to use the green function here. G of x equals 2x squared plus 3. So what I do is I take and I use this function. Now, in the green function, g of x, everywhere I see an x, I'm going to kick it out and replace it with a 3. Remember, make sure you go ahead and always plug it in your calculator using parentheses. So we plug it in 2 times 3 squared plus 3. Now you can plug this in your calculator and evaluate it, or do order of operations. 3 squared is 9. 9 times 2 is 18. 18 plus 3 gives me g of 3 is equal to 21. If I had to gather an ordered pair here, input 3, output 21. Now letter B asks you to evaluate h of 7. So which function do I use? The yellow, the green, or the blue? Well, in this case I would use the blue. I would go to function h. So function h tells me to replace x with 7. So here I would do 2 to the 7th power. So when we go to our calculator and evaluate 2 to the 7th power, what do we get? Alright, when you do it, what do you get? You get 128. Alright, and the last one, okay, evaluate f of negative 20. When I do that, f of x is the function I would use, which is the one in yellow. So I would use the yellow function, and everywhere I see an x there, I'm going to replace it with negative 20. So f of negative 20 equals negative 5 times negative 20 plus 2. So f of negative 20, right, equals 100 plus 2, which is 102. So f of negative 20 is equal to 102. All right. Both of these allow me to gather ordered pairs. You know, letter B, the ordered pair would be input 7, output 128. Letter C would be input negative 20, output 102. Okay. Now, why is this beneficial? Well, when we have graphs, we basically use an input-output table, or we evaluate the function at different, using different input values. And we gather ordered pairs and we plot them. So it says here, find the range of each function with a given domain. Gather the ordered pairs, plot the ordered pairs, then sketch and label the graphs. Now, these are typos. Let letter A be f of x. We're going to let letter B be r of x. We're going to let letter C be, we'll just go g of x. Okay? And there's a reason we're doing that. Now, we're going to just highlight this in yellow. We're going to highlight this one in blue. And we're going to highlight this one in green. Now, the first function, f of x. We are given the domain. And you got to remember, domain is your x values. Right? So, given this domain, we want to find the corresponding range. Okay, but then we want to basically go ahead and find the ordered pairs also. So the first one we're going to evaluate is f of negative 3, meaning we're going to input negative 3 into this function. So we get negative 3 plus 3. Well, the opposite of negative 3 is 3, and 3 plus 3 is 6. So f of negative 3 is equal to 6. So we can gather an ordered pair here, negative 3, comma 6. Second, we're going to use the input 0. F of 0 is equal to negative, substitute 0 in for x, plus 3 gives you 3. So an ordered pair I get here is going to be input 0, output 3. The last one, I'm going to use 3 as my input. F of 3 equals negative 3 in parentheses plus 3. Think of this as negative 3 plus 3, which is 0. Now my ordered pair is negative 3, or positive 3, comma 0. So now I can plot these ordered pairs. Negative 3, positive 6. 0, 3, and 3, 0. And when I connect them, I get this. Now, to help myself know which function I just graphed, I'm going to name that f of x. So I know that's the function f. The second one I'm going to do is r of x. So I'm going to evaluate r of x when x is negative 2, 0, and 2. So the first one, r of negative 2 equals 2 times negative 2 squared. So r of negative 2 is going to be negative 2 squared is 4 times 2 is 8. What's my ordered pair here? Negative 2 is my input, 8 is my output. The next one I evaluate, r of 0 equals 2 times 0 to the second power. Oh, that's real easy because 0 squared is 0. Anything times 0 is 0. Ordered pair, 0, 0. And finally, I'm going to evaluate r of 2. 2 times 2 squared. R of 2 gives me 2 squared is 4 times 2 is 8. My ordered pair here, 2, 8. So now when I plot these points, negative 2, 8, then 0, 0, then 2, 8, and now if I connect these, I get something that looks like that. Now I can name this function r of x, so I know which equation it goes with. And finally, I have g of x. Okay, g of x, I'm going to evaluate it when it's 0, 4, 9, 16, and 25. So, g of 0 is the square root of 0, which is 0. Ordered pair, input 0, output 0. G of 4, what is that going to be? Well, the square root of 4 we all know is 2. Ordered pair, input 4, output 2. Next, we're going to evaluate the function when x is equal to 9. G of 9 equals the square root of 9, which is 3. Ordered pair, input 9, output 3. G of 16 equals the square root of 16, which is 4. So input 16, output 4. And finally, G of 25. Input 25 in for x, and we get the square root of 25, which is 5. Ordered pair, 25, 5. Now, I know not all of these points will land in the coordinate plane provided, but kind of get an idea by plotting all the points you can. So you get 0, 0, 4, 2, 9, 3. If we did 16, it'd be 16, 4, which would be somewhere maybe here. And if I connect those dots, this is what my graph would look like. Now, that's the graph of the square root of x, which now we can name as g of x. So if I ask you guys to, which graph represents, 2x squared, to look at the blue graph because it's labeled r of x on that graph. Okay, that is function notation. So take the time now to go and finish up the day 5 homework on function notation. It's the extension of the homework assignments